Say it again.
Change it to the radical.
Yes, that's what I want to do. How? This is the
Fourth root,
fourth root of.
x minus 4.
Very good. Do we all agree with x minus 4 to the third power as being the radicand and the fourth root? Okay, excellent. Good. We had something similar last time, but let's work on another problem, like 52 on. That's it? That's it. Okay, let's discuss it. Thank you so much for asking, Jackie. So here's the reason why this is final. Because the power is smaller than the index. If the power is equal or more to the index, then I have to further simplify it. But since the power is less than the index, there is nothing I can do here. It's like saying this. The fourth root of 2 to the third power. There is nothing I can do. But what if I have power 4 here? What will the answer be? So if they are the same, the answer will be 2 over raised to power 4 over 4. What if I have this? This is much more than the index. Well, actually, it's a double. So you write 2 to the second power. And I'm going to get to this in a minute, but since you asked, it's a very good question. What will I do with this? Okay, so I'm coming back to 52 in a minute. But I want to discuss this because Jackie is way ahead of me. She probably finished chapter 10 in my last class already, didn't you? I didn't look today. You did? You did? She's like 6 sections ahead of me. Okay, what do I do now? Well, obviously, 7 is not divisible by 4, right? Here, 8 was divisible by 4, and I got 2. The radical is going away, and it's done. So what will I do with this? Since 7 is not divisible by 4, I can split it. But I want you to tell me how to split it. X to some power times x to some other power. Let's go back 1. So here's one way. 7 over 4, no. Go back 1. 6 over 4, no. Go back 1. 5 over 4, no. Go back 1. 4 over 4. So then how will I split x to the 7th so I can simplify this radical? Right now it's not fully simplified because the index is bigger than the, the power is bigger than the index. So how will I split that x to the 7th? And this is what we started with today when Becky said, go back to my exponential notations and review those. Yes, Mike, go ahead.
X to the 4th and x.
Right, of course. X to the 4th and x to the 3rd. Copy the base and add the exponents. Excellent. So once I write the 4th root of x to the 7th, that's x to the 4th and x to the 3rd, then I know how to simplify it. It's a product underneath. So which rule do I apply here? Yes, of course. The product rule, thank you. Assuming if everything is positive, now I can simplify it. And how do I do that? So don't worry about the absolute value. Let's assume for a moment that all radicands are positive, are made with positive numbers. This I know.
It's x.
Exactly. Unless I need to use the absolute value. Can I further simplify this? No, because I'm back in the same situation when the index is smaller than, when the power is smaller than the index. So all I have to do is just say this is x, the 4th root of x to the 3rd, and I'm done. So that's what I do when I cannot divide. Here I was able to, here I was able to, but here I wasn't. Because 7 is not a multiple of 4. Or if you want, 4 is not a divisor of 7. So, but I can split it. And how? I can go over 7. So I can split it into 4 and 3. Very good question. Thank you. Okay, so I picked 52. Here it is. 52 on 601. So I have a raised to 1/4 times a raised to -1/2 and divided by a raised to 2/3. What do we do now? Anyone has any suggestions here? You could say, let's go back to radicals, and I will definitely say no. There will be a big problem if we do that. So we did a problem last time. So what do you recommend? Right, exactly. So copy the base, add the exponents. Do not add them. Just leave them alone for a moment. Divided by a to 2/3. Okay. Then, now I have two exponential notations, one at the top and one at the bottom. How do I divide them?
Subtract the denominator.
The exponent of the denominator from what I have at the top. Very good. So then I copy the base, and I have 1/4 minus 1/2 and minus 2/3. This doesn't really look like a 1/2. Good. So now, what am I looking for? What do I need to do? The least common denominator, which is? Indeed, very good, excellent. I need adjustments at the top of all three. What is the adjustment for the top of the first one? Very good. Second one. Very good. Third one. Perfect. What do I have at the top then? I need to write the intermediate step for everyone to see, and then we can calculate.
3 plus 6 plus 4.
3, careful, because there is a minus.
Minus 6.
Minus 6. Minus 8. Do you all agree with 3 minus 6 minus? That's okay. Do you all agree with 3 minus 6 minus 8? Okay, what is that? Negative 11. I completely agree. So this is a to negative 11 over 12. Okay. Now we already made progress with this by showing that example in which we said no negative exponents in the final answer. 2. The exponents under the radicals are numbers smaller than the index of the radical, not even equal to, smaller. We know that at least from one example. And there are no radicals in the denominators. In order to consider radical notation fully simplified, what do I do next then?
Put it over 1.
Yes, very good. So this is indeed 1 divided by a to 11 over 12. Now this, I know it's a radical. How do I know it's a radical? One more time. Can anyone say, how do I know that this is a radical in the denominator? I don't see any radical there. How do I know it's a radical?
Very close to it.
Because the exponent's a fraction. Every time I see a fraction as the exponent, I know it's a radical. Okay, can anyone give us what radical is that?
12 root
The 12th root. Very good, Riley.
of a to the 11.
A to the 11th. Okay. Now, I'm coming back to, yes, Becky?
So it's 11. You went from a
You mean from this one here?
negative positive.
Remember that's the last rule from the exponential rules that we reviewed? This one, the last one. Right? So a to negative exponent 1 over a to the positive exponent. Okay. So is this clear? The conversion from here to here, is that clear? Okay, good. So now I have another problem. And here is the problem. What is the problem?
It's a radical denominator.
Good. What did we do last time to eliminate that problem?
Rationalize.
Excellent. We rationalized. Which radical do I need to rationalize by? Can I put the 5th root in there?
It has to be the 12th.
It has to be the 12th root. Excellent. The 12th root and the 12th root. And now I'm thinking, what am I missing? What am I trying to form? I'm trying to form and have 12 total. Because only if I have 12, the index 12, the power 12, then the radical goes away. But I only have 11. So I'm missing what?
1.
One of them. So I'm missing an a, indeed. So then the numerator is the 12th root of a. But what about the denominator again? What was the target? Did I accomplish my target? Exactly a, indeed. So now, yes, Becky? You had a question? You want to explain this again? Okay, let me know. Any questions here? Yes?
What was that question asking?
Oh, the question was asking us to use the properties of exponents to simplify each expression. Write with positive exponents. We went further.
Okay, so
We went 2 steps further than what the book was asking us.
all of them got eliminated.
Yes, say it again. The radical?
All of them got eliminated.
Yes, because when we multiply these two, we multiply a to the 11th by a, copy the base, add the exponents, and we get 12. And the 12th root of a, let me write it for you. The 12th root of a to the 12th is a. Okay? So when we multiply the 2 numerators, we get this. When we multiply the 2 denominators, we get the 12th root of a to the 12th, which is, assuming everything is positive, otherwise it would be the absolute value. But it's 12 over 12, which is 1. Is that okay? Better? Okay. The reason why we went further with one more step is because we talked about rationalizing last time. But rationalizing is really not in section 12.2. It comes further down the road, but I don't want to wait. Because I don't want to say to you, when we get to section 12.4, oh, by the way, I lied to you. In sections 1 and 2, we really have to go one more step. So I really wanted you to see. That's why I start with all the rules from the beginning, and I don't wait till section 12.4 for rationalizing. Good, perfect. But yes, you're right. So be careful when you put your answers in MyLabs Plus, because you may only say, write it with positive exponents and stop right there. Don't continue rationalizing. Yes, very good point. I agree. Okay, so let's also look at, see how we can simplify radicals, like I'm on page 602, and I like to look at problems 73 through 84. And then we can continue. Let's say, problem 82. And this is the square root of 10, a to the 5th, b to the 5th. You could say, this is fully simplified, because that's what I said before, right? I said the exponents under the radicals are numbers smaller than the index, and they are. And it's done. Well, the answer is not true. There is one step that we can still perform here and simplify it. So, first of all, I would like you to give me the exponential notation for this. We can split it first of all if you want, if that's easier for you. We can write this. I hope you agree. Do we agree with this step from here? Okay, now let's change these two into exponential notations. A raised to which power?
5 over 10.
Right. And b raised to which power?
5 over 10.
It turns out that we can simplify those fractions. 5 over 10 is similar, or the same, I should say, with what? Exactly. And the same. And now I can go back. So I have two factors raised. Happens that they have the same power. I only needed the denominator to be the same, and the denominators are the same. So how do I change this expression into a radical then?
Be the square root of
Exactly. So yes, from the 10th root of blah, 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 to change it into the square root of AB, it really simplified it. Okay, I think we had enough of that. We can continue with section 10.3. Let's look at problems from 10.3. Okay. So let's look at problem 12. on page 609. So this is the fourth root of AB squared times the fourth root of 27AB. It says use the product rule. So we're going backwards on the product rule. Let me refresh your memory on the product rule. So the nth root of A times B is the nth root of A times the nth root of B. But this is an active relationship, if you want, or interactive, or going back and forth. If I have this, I can get this. If I have this, I can get that. And now, of course, I have this. So I'm going backwards. So since the indices are the same, because I can't use this if indices are not the same. So if this is 3 and this is 7, of course I cannot write this. So, but they are the same. So I will write the fourth root of what?
AB squared.
Right. So let's write the constant first. It's okay. You can rearrange it. You don't have to do it in one step. I'm fine with that, Riley. Okay. And then A, you're right, squared, and then B. Exactly. So first of all, disregard the constant for a second. Is this, if I didn't have this in here, was it fully simplified? Yes, because the power is 2, the index is 4, power 3, index 4. But I also have to look at 27 to see if there is something that I can simplify there. But it happens that 27 is the same with, I want the base and the power. Very good, excellent, thank you. So therefore, the power is 3, the index is 4, and I can now conclude this is it. Not even the constant can be further simplified or taken out of, or a portion of it, or a factor of it taken out of the radical. Any questions on that? Any questions? Okay, let's look at a ratio. As I said before, when we play with these rules, this particular chapter, beginning of it, is not as exciting as we would love it to be. But we need to practice these rules because they are necessary for what follows next. You're not going to see a lot in the, these, but once we establish the rules and we understand the rules, then we can move on. Okay, so again, the question here is asking us to use the quotient rule to simplify. What do I do? We had a similar example before. So I have the negative in front, and then
Cube root of 64A.
exactly the cube root of 64. I can also say the cube root of A and the cube root of B to the 9th. I'm using the product rule and the quotient rule at the same time. Okay, so then what follows here? I already determined with the graphing calculator, and I know now that the cube root of 64 is yes, indeed, 4. Can I do anything to the cube root of A? No, of course not. And what about the cube root of B to the 9th? B to the 3rd, indeed. Very good. Excellent. Okay, so let's look at exactly what Jackie made me do 10 minutes ago. We finally got to examples of that kind. So let's look at problem 58. 58 on 610. And this is the cube root of 8a to the 6th, b to the 9th. This is kind of a warm-up. So I'm asked to simplify. It says see examples 3 and 4. I won't show you examples 3 and 4 somewhere in the book. We know what to do. We don't need to see examples 3 and 4. So any suggestions here? Right. I recommend, of course, now since you got used to it, you can skip some steps. I'm fine with that. But for everyone to see, I will write this, a to the 6th, and the cube root of b to the 9th. I write the intermediate step for everyone to see. But yes, I agree. If you want to skip this step, I'm fine. So how do I simplify the cube root of 8? 2. How do I simplify the cube root of a to the 6th? Very good. And how do I simplify again the cube root of b to the 9th as b to the 3rd? That's it. Good. So this was a warm-up. Let's look at problem 60 now. Any questions for me, please? Any questions? Yes, Becky?
Can I see the paper?
Yes. You want the previous one?
Yes.
I'm giving you the previous two. So problem 60. Okay, let's take a look. The fourth root of 162 x to the 7th y to the 20th. Okay. Before we look at the number, I will have a claim. And here's my claim. I like one of the factors and I don't like the other one. Which one I like and which one I don't like? I like the y to the 20th or I don't like y to the 20th. I do. Do I like x to the 7th? No, because 7 is not divisible by 4. So I have to work on x to the 7th. We just did a similar example a few minutes ago. Now let's look at 162. I have no idea what 162 is. So let's break it up. Since it's an even number, it must be divisible by 2, indeed. So this is 2 times. Very good. Okay. What do I know about 81? Is there something I can say about 81? Something like a base raised, yes?
You get it by multiplying 9 times 9.
9 times 9, but I want the prime number. You're right. So is there a prime number raised to a power? But 9 is not prime. Exactly. So this is the same with 3 raised to the... So it's 9 times 9. I have 2 3s in 9 and 2 more, exactly, and 2 more in the other 9, right? Good. So then I know I have my idea of how to break up. So can anyone tell us how to break up then 162 x to the 7th y to the 20th? How do I break up 162 then? Yes, 2 and 3 to the 4th. Excellent. That's 162. How do I break up x to the 7th? And can you tell me which dictates here? Look at all these numbers and say, oh, I know. That will dictate, will tell me how to split x to the 7th. What am I referring to? The index. The index tells me how to split x to the 7th. How do I split x to the 7th? Knowing that the index is 4. Excellent. X to the 3rd times x to the 4th. Awesome. And I don't have to do anything to y to the 20th. Why I don't have to do anything to y to the 20th? Because is divisible, 20 is divisible by 4. Okay, very good. So now, which of these factors will come out? Will 2 come out of the radical? No. Will 3 to the 4th come out of the radical? Yes, this will come out. Will x to the 3rd come out? No, because it's 3 and 4. Will x to the 4th come out? Yes. Will y to the 20th come out? Okay, so please tell me what is in front. I already know what will be left. The fourth root will be applied to what? What I cannot simplify. What I cannot simplify is 2x cubed. But I have to decide what to put in front. So what am I taking out?
3x.
A 3. I'm taking out an x. I'm assuming everything is positive, so I don't have to worry about absolute value. And what else? Very good. Excellent. Now this is fully simplified. There's nothing else we can do here. It is indeed 3xy to the 5th times the fourth root of 2x cubed. Absolutely. Any questions? Okay, I think we need to practice this more. Would you agree? Okay. Would you like to choose, or you trust me? Or we can also look at rationals, fractions. And then I would like to look at the distance formula and the midpoint formula here. So, do I choose? Okay. So I'm going to choose, let's work on another product. 53. Negative outside, the square root of 32, a to the 8th, b to the 7th. Okay. Again, I claim that at least one, I don't know about the number yet, but I claim that one of them I like, one of those factors I like, and the other one I don't. Which one I don't? Yes, I don't, because 7 divided by 2 is not an integer. Good. So I'm thinking now of 32. It's an even number, so it has to be divisible by 2. What else is left? 16. Perfect. So then I have negative in front, and I already know how to split 32. Because 32 is not a perfect square, and 2 is not a perfect square, but 16 is a perfect square. And the index dictates. The index, which is 2, tells me what to do and how to split everything. The index is the powerful element here. So 32, instead of 32, I will be writing, right? And then a to the 8th stays. And how do I split b to the 7th? And you cannot say b to the 4th and b cubed, because now the index is not 4. The index is 2. So 7 over 2, no. Go back 1. 6 over 2, yes. So how do I split b to the 7th, knowing that the index is 2? B to the 6th times b, indeed. And now I know what comes out. What comes out? This will come out, this will come out, and this will come out, for sure. What is left inside? So negative is outside. What will be left under the square root, because there is nothing I can do about it? 2b, of course. So please tell me what comes out then. The square root of 16, which is 4. The square root of a to the 8th.
A squared.
Careful. A to the 4th, because it's 8 over 2. And b to the, that's it. So the final simplified form is negative 4, a to the 4th, b to the 3rd times the square root of 2b. Do we need another example? Yes? 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 Say yes or no. Let's look at a ratio. 74. So it's the 4th root and the 4th root, and the top is 160, x to the 10th, y to the 5th, and 2 x squared, y squared. Now, these two radicals have the same index. Furthermore, this is very important. Not just that they have the same index, but what is also important is they have same factors inside. Okay? Versus this. I meant to write this actually because I'm talking about this. I'm talking about the same thing. So allow me to correct this, or I shouldn't correct it and just go back to the next page, or here. So this, they have the same index, but 2 and 3 have no common factors. There is no point. I'm not saying it doesn't equal 2. I shouldn't say that. There is no point in writing this. I can simplify. We're going to have to do something else with this, which is rationalize the denominator. So there is no point in changing this one into this one. But there is a point in changing this one into 1/4 root. Why? Because I see common factors, and I can simplify. Here, there is nothing else to do. So I'd rather keep it like this and rationalize it. And that's what we're going to do. So then I have the 4th root because I know the rule. This is one of our rules, the quotient rule. This is the quotient rule right here. And it goes back and forth. I can have the nth root of a over b equals the nth root of a over the nth root of b and then go back. So this is, again, an active relationship. So the numerator is 160, x to the 10th, y to the 5th, and the denominator is 2x squared, y squared. There is a point. There is a reason why I write the radical over the radical, the 4th root over the 4th root into 1/4 root, because now I'm hoping that I can get rid of a lot. So I have the 4th root of what? Of course I have to divide 160 by 2 and I get, very good. Of course I have to divide x to the 10th by x squared and I get, copy the base, yes, x to the 10th divided by x squared, copy the base and subtract the exponents, yes. Did I say divide? The exponents? Did I say, no, I said when we divide x to the 10th by x squared, we copy the base and subtract the exponents. What happens with y? Copy the base, subtract the exponents, and I get, yes, 5 minus 2, 3. Good. So now, this I like. This I like too, because I can't do anything to it. I don't have to, because this is 3 and this is 4. This is done. This will easily come out, but I have to work on 80. The 4th root of 80 is not an integer. So 80, again, it's an even number. It's divisible by 2, so I get 40. 40 is divisible by 2, so I get 20. 20 is divisible by 2, and I get 2 and 10, and then 2 and 5. And I like this, because this is what times what? So 80 equals this times this. Yes, or 16 times 5, same thing. 2 to the 4th times 5, same thing. Whatever you want. If this is easier for you, write that. That's perfect. Good. That's even better. So this is the 4th root of 2 to the 4th times 5 times x to the 8th times y to the 3rd. And what is the final form then? This will come out. This will come out. And what is left under the 4th root for sure? Because we can't simplify it anymore. 5y cubed indeed. So what is left outside? Or I'm sorry, what comes out? Two x squared. Do we need more examples? Either product or ratio. Is there a yes? Yes. Ratio? Yes. Perfect. Let's do ratio. 76. Any questions? So this is the final simplified form. 76. So this is the 5th root of 192 x to the 6th, y to the 12th, everything divided by the 5th root of 2x to negative 1, y to negative 3. Is there a point of rewriting this with the same index? because I see common factors. Otherwise, I wouldn't bother because I'm now going to be able to simplify. But since the indices are the same, I will write the fifth root, 192, x to the sixth, y to the 12th, over 2, x to negative 1, y to negative 3. Perfect. What do I do next? So, no, just simplify. The fifth root of 192 divided by 2, 96 indeed. X to the 6 divided by x to negative 1, I copy the base. What happens with the exponents?
Okay.
From 6, I subtract negative 1. What do I get? 7. I copy the base. From 12, I subtract negative 3. 15. Okay. At least when it comes to the variables, I like one of them, but I don't like the other. Which one I like?
Right.
Right, because 15 divided by 5 is 3 and I'm done. But for this one, I have to work on. And then I also have to look at 96. It's an even number, first prime number, 2. And then this is it 48? And then 2 again, and I get 24, and then 2 again, and I get 12, and 2 again, and I get 6, and 2 again, I get 2 and 3. Nice. So what can I say about 96? And what can I do to x to the 7th? And remember, which number dictates here what to do? Which number tells us what to do? Index, which is 5. Perfect. So 96 is the same with 2 raised to the 5th power, indeed, multiplied by 3. And x to the 7th, exactly. So in order to figure it out, you just go back 1. 7 over 5, no. 6 over 5, no. 5 over 5, yes. So it's 5, and the rest is 2. Perfect. So if you want, you can rewrite it. If you need to see it again, let's rewrite it as the fifth root of 2 to the 5th times 3 times x to the 5th times x squared times y to the 15th. If this helps you, please write the intermediate step. And I know what comes out, right? This will come out, this will come out, and this will come out. I can already write what is left under the fifth root, so I don't forget it. What is left under the fifth root? That's it. Good. So what is goes in front? 2xy to the, that's it. I've seen the following mistakes or mistake in tests, papers, and so on and so forth. Students write this. Square root of 81 is the square root of 9. Is this correct? No. Once you apply the square root on 81, you're done. You don't have another square root in there, right? So the answer is not the square root of 9, but it's just 9. Okay, perfect. I know I have 10 minutes left. Let's just talk about the distance formula and the midpoint formula. And then we'll stop, promise. Now you have everything between 10.1 and 10.4. This is all done. Please start working on MyLabs Plus. Please bring a list of questions. Please write them down. If you have difficulties with any problem, I would like to solve it with you. So please write them down and bring them to class. I'm sorry, forgive me. It's 3. Yes, 10.1 to 10.3. 10.4 is the next step here, adding and subtracting. Okay. So let's take a look at the following scenario. Let's suppose I have a point here, A. Let's say I have a point here, B. Point A is my first point, so I'm going to give it the coordinates x1, comma y1, because that's my first point, and B as x2, comma y2 as being my second point. And I want to be able to determine the distance between these 2 points. I want to find this distance of the line segment between A and B. Okay. Can anyone give us the coordinates of this and the coordinates of this? How much is this? And how much is this? And you cannot give me a number. You have to use what I have in here, in the figure. So what could this be? If this has x1, y1, how much is this? So if this is 5, 6, how much would this be? 5, right? 5, 6, this must be 5. So this must be 6. But I have notations, so how much is this then? How much is this? That's it, must be. Good, so this piece, this is x1. This piece is y1. So right here, this point, y1. Okay, I will do the same thing with b. How much is this right here? Very good. And how much is this right here? Good. So now, of course, I'm going to form a right triangle. This right triangle. Can anyone give us this distance? And I can only use what I have. And then I would like you to give me this distance. If this is x2, and if this is x1, how much is this? Of course, x2 minus x1. Excellent. x2 minus x1. Good. If this is y2 and this is y1, how much is this? Good. So I have a triangle. I'm going to take it out of there so we can talk about it. So I have a triangle like this, where this is a distance that I don't have. I know that this measure is y2 minus y1, and I know that this measure is x2 minus x1. And I have a theorem that I can use or apply in a right triangle. What theorem is that? Right. However, be very careful when you say a squared plus b squared, you have to refer to the legs equals c squared, and the last one is the longest, right? The hypotenuse. So I have to write that the hypotenuse squared equals the sum of the squares of the legs. Now we're going to apply a procedure that we haven't really learned it yet. So I want to talk about it for a second before I apply it. A while back we solved this equation. How did we solve it? This is a very important procedure. I know I have only 5 minutes left. What did we do? And we have an agreement on this. We have our contract. What do I do with this? Yes, how do I factor it? So then I have two options. X plus 2 can be 0, which makes x equals very good. And x minus 2 is 0, it's okay. And when x equals 2. Okay, here's another procedure called taking square roots. But I have to be careful because something is very important here. So instead of solving this equation like this, I want to do this. I want to separate the variable, the x squared, from 4. So I'm moving 4 to the other side. And then I will take square roots from both sides. I want you, before we look at the right-hand side, I want you to give me the answer of the left-hand side. I'm asking you the square root of x squared, and x can be any real number. Careful. It's a square root. X can be any real number. So the correct answer is? Thank you. And the square root of 4 is 2. Now I'm back to chapter 9. How do I solve this? We had a quiz last time. Very good. See, that's how I get these solutions. Because of the absolute value. Because we learned in this chapter that the square root of x squared for any real number is not x, but the absolute value of x. So this is the procedure I will apply here. Because I'm not interested in the distance squared. I will apply the square root to both sides as we did here. But since the distance cannot be a negative number, what does the square root of d squared equal to? Not the absolute value of d. Because d is a distance. It can never be negative. So in this case, the square root of d squared equals only plain d. So this is the distance formula. Distance formula. Distance formula. And I have it somewhere on my handout because I put everything in there. Here it is. So this is the distance formula. D equals the square root on page 5 at the bottom. The square root of, we're going to go over this handout one more time, maybe two more times before we take the next test. So this is the distance formula. And this is the midpoint formula. Okay. I know I only have 3 minutes left. I just want to show you how to calculate the distance. Give me two ordered pairs, any two ordered pairs that you can think of. So we can find the distance and then we'll stop. So give me any two ordered pairs and we'll find the distance. I know you're tired. I'm sorry. Sorry, Mike. I know you're tired. Any two ordered pairs, please. 2 and 3. Oh, let's say -6. Okay, very good. So this is my x1, y1. This is my x2, y2. I put them carefully under the distance formula. And by the way, I didn't simplify. Can I simplify the distance? Can I take the square root of a sum? No. This is it. Nobody can simplify that. Good. Perfect. So I'll put x2 right here 4 and x1 right here 2 and then y2 -6 and then 3. Again, if you have a different method, I'm fine. Okay. 4 minus 2. 2 squared. 4. Be careful because I've seen it in the past. Students write something like -4. -4 plus 5 or -4 minus 3. Is that possible? What type of quantity is this? What type of number will this be always? Positive, it's squared, right? What type of number will always be this? And if I add them, I can never have negative under the square root, right? For the distance, right? Okay, so then -6 minus 3. -9 squared. 81. Remember, you cannot split this radical. Don't fall, in that trend, right? So d the square root of 85, and this is it. I could possibly simplify. Let's see. So 85, it's 5, and 17. No, I cannot simplify. This is it. So the distance between these 2 points that you picked is the square root of 85. Yes, I can approximate it.